everyone, my name is Maddie and I'm the narrator today, and this is Cynthia, and we're here to talk to you about UV radiation and the sun. What is the sun? It is a really big and hot star. It's basically a giant burning ball of gas that lights and heats our planet. Visible light, all the colors we see, and infrared radiation, the heat we feel, are two different types of waves on the electromagnetic spectrum, and they come from the sun. The electromagnetic spectrum isn't just visible light and infrared radiation, though. There are many other different types of waves, from the radio waves you hear through your radio, to the microwaves you use to heat up your hot chocolate and chicken nuggets, to the X-ray and gamma rays doctors use to see inside your body when you're hurt. And we group all of these waves by their length. A wavelength is the distance between two consecutive peaks of a wave. Gamma rays at this end of the electromagnetic spectrum are really short, so the distance between two consecutive peaks is really, really tiny. On the other end of the spectrum, radio waves have really long wavelengths. The sun emits all wavelengths in the electromagnetic spectrum, but the majority of what reaches us here is in the form of visible, infrared, and ultraviolet radiation. Why am I calling it radiation? Because it is radiation. Electromagnetic radiation is a form of energy called photons that travel in waves. I know radiation makes most people think about nuclear disaster, but lots of really safe and necessary types of light are considered radiation, like the infrared waves that cause heat, or visible light waves that give us all the colors we see around us. But UV light is what I'm here to talk with you guys about today, because every day we are exposed to UV radiation, and although we can't see it with our naked eye or really feel it when it's like hitting us, it's really important to talk about. There are three types of UV radiation: UVA, UVB, and UVC. Only UVA and UVB reach us here on our planet, Earth. Our pretty little planet Earth. UVC is actually filtered out by the ozone that surrounds our planet. Both UVA and UVB radiation can cause damage to your skin, which is why it's important to wear sunscreen and cover up when you're out playing in the sun. If you get a sunburn, it's a sign of short-term overexposure to the sun. And wrinkles are a side effect of prolonged UV exposure over a lifetime. Hopefully you are joining us today because you've come into possession of one of our UV bracelet kits. Your kit contains a pipe cleaner, regular pony beads, and several special UV beads, these off-white ones. And when they're in the presence of UV radiation, they will react and change to a secret hidden color. You can't see the UV rays with your eyes, but you can use the UV beads as an indicator of when ultraviolet light is present by watching for a color change. How cool! So, your science mission is to take these beads and make a bracelet, and then go outside and do some of the different experiments and understand how UV radiation works. Ready, guys? Let's go! To start our bracelet construction, we're going to use some pipe cleaners and some UV beads. This bracelet is going to go purple, yellow, blue, pink with its color changing. To make your bracelet, string them all on the pipe cleaner and then turn it into a bracelet shape and secure it on your arm or off your arm.
Now it's time to take our bracelets to the sun. Experiment time.
Time for phase 2. We are taking this outside. Yay!
Objects that block the sun, such as fabrics, trees, water bottles, or sunglasses.
Use different items as a screen for the UV light to see how they affect the color change of your beads.
Use these different items as a guide to experiment how it affects the beads.
Use the regular pony beads and compare how bright your UV beads get depending on what thing is filtering the light.
Use these different kinds of light to continue to figure out the properties of these UV beads. Happy experimenting! Okay guys, here's the final reveal. Ah. Oh wow, look at those colors!
Look at that wrist. Whoa.